Hey guys, how you going? Hope you guys all had a good holiday and a good break. Hope you guys had a good Easter and rested up well. So I'm in Japan for the next few days. So what I'm doing is I'm making videos instead of me getting you to just watch some other videos. I'll make my own. I'll walk you through what we're doing for the two lessons that I miss, and then I'll be back. So yeah, so we're going through chapter 9 now, which is probability. And I know it's not everyone's favorite thing, but I'm going to try my best to make it a bit more enjoyable, make it a bit more understandable. So how it's going to work is you're going to see my face in the top left, unfortunately. Sorry for that. But then you'll see my iPad here. And just like normal, I'll be writing down my notes, going through a couple word examples, and then I'll give you the questions. Now, we finish the questions early. I have extension questions, and then I also have an extension worksheet, which is on the Google Classroom. So if you finish early, go ahead and do that. So I'm giving you the whole two lessons to go through 9A. So watch this video, have you got the questions in that lesson and also in the next lesson. And if you finish early, then you do the worksheet. All right, let's get straight into this. So what we're going to do is we're going to start off with some definitions. So I just want you to write this with me. Let's go through some definitions that will just help us a bit later on with everything as well. So let's make this nice and big. There we go. All right, so the first thing we're going to define is sample space. Now, this is supposedly meant to be revision from last year. However, it's easier if I assume you have no knowledge just so I can fill in the gaps. So when we're talking about sample space, we're talking about probability, remember? So we're talking about the chances of something happening. So for instance, if I'm rolling a dice, what's the probability that I roll a 1? Or if I'm flipping a coin, what's the probability that I'll get a heads? Or what's the probability that it's going to rain tomorrow? Or what's the probability of Mr. Solomon's walking in right now behind you? You know, like that's all we're talking about for chapter 9, which is probability. So, sample space, we're talking about sample space. We're talking about a list of all of the possible outcomes from an experiment. Now, in probability, if I flip a coin, that is considered an experiment or a trial. So that's what it is. So, for instance, let's go ahead and write, for instance, so example, when rolling a dice, the sample space is, so when rolling a dice, the sample space is, now sample space means all the possible outcomes. So I want you to think about it for a second. If we're rolling a dice, what are the possible numbers that we can get? Well, we can get 1, 2, 3, 4, 5, or 6. So those are all our possible outcomes. So this is what we'd write. So what you do is you do a squiggly line, then you write all the possible outcomes. So 1, 2, 3, 4, 5, and 6. And we do the squiggly lines again. So when you see the squiggly lines, you know that they're talking about sample space. So all the possible options that we can have. Now, the second definition that we're going to go through is something called the complement. Now, this is a theoretical one. So we'll do an example later on where we see the complement. But for right now, I just want you to write the definition. So, the complement of an event. Now, when I say event, if I say what's the probability of rolling a 6, the event is rolling a 6, right? So it's just what we're looking for. So the complement of an event is the probability of that event not happening. So there is a formula for this, and I'll explain it in a sec. But let's say I say, what is the complement of rolling a 6 on the dice? So what we think is, well, we want that not happening, so we want all the options where we're not rolling a 6. So, well, we have 5 other options out of a possible 6, so it's 5 6. There's a formula. So the formula says the probability, so PR means probability, of not A. So we say not the event happening, not A. So A could be heads, A could be rolling a 6, A could be doing a backflip. So the probability of not event A is equal to 1 minus the probability of A happening. So essentially what that means is, because in probability everything can only be out of 1, so a maximum number is 1, minimum number is 0, we do 1 minus the probability of A. Again, this is just theory, so don't stress if you don't get it. We're doing a work example. So here's what this means. So let's say example, what's the probability of not rolling a 3? So we have a dice, and what's a probability of not rolling a 3? So we know it's a complement of 3. So what we need to do first is we need to figure out the probability of rolling a 3. Right, so in this case, the A is rolling a 3. So what we'll say is the probability of rolling a 3 is equal to, well, on a dice, how many 3s are there? There's 1. So we go 1 divided by how many options are there on a 6-sided dice? Well, we can get 1, 2, 3, 4, 5, or 6. So there's 6 options. So we say the probability of rolling a 3 is 1/6. So then if we put that into our formula before, we know the probability of not 3 is equal to 1 minus 1/6. Pop that in your calculator, you get an answer of 5/6. So that's what the complement means. Now, let's also go to the next page. And let's just do, can I zoom in? There we go. Some other important notes. So other notes. So when we're talking about probability, these are things we kind of want to keep in the back of our head. All right. So the first thing is that probability can only range from 0 to 1. All right, probability can only range from 0 to 1. So when we're getting an answer for probability, it should be between 0 and 1. When we're talking about probability, 0 means it's impossible, and 1 means certain. So if I said, what's the probability of rolling a number from 1 to 6 on a dice? Well, we can only get from 1 to 6 on the dice, so our answer is going to be 1, which means it's going to happen. The second thing to note, so number 2, is that probability can be written as a decimal, fraction, or percentage. So what that means is, if I'm asking for the probability, let's say the probability of flipping a coin and getting heads. Well, we know that when we flip a coin, there's a possible of 2 options, heads or tails. So it's a half, or we can say it's 0.5. Another way of writing that is a half. Another way of writing that is 50%. What I might do is I might just do it like this. equal to a half, which is equal to 50%. So all three of these are valid answers. So when we're talking about probability, you can get an answer as a decimal, a fraction, or a percentage. So if we're talking about decimals, it can go from 0 to 1, fractions can go from 0 to 1, and percentages can go from 0% to 100%. So that's some theory out the way. Let's move on now to probably the most important part, how to calculate probability. Let's write that neater. How to calculate probability. Sorry for it being messy. I'm writing it while it's on my hand. So, how to calculate probability. Let's do this nice and big. When you're doing this, make sure it's nice and big so you know. So there is a formula. The formula to work out the probability says the probability of any event happening. So event could be what the question's asking. So if it's rolling a 3, the event is rolling a 3. If it's flipping a coin and getting heads, the event is getting heads. If it's the probability of, I don't know, Mr. Solomon's doing a somersault, would say PR, Mr. Solomon's doing a somersault. So that PR means probability, and whatever's inside the bracket is the probability what we're looking for. So we say the probability of an event happening is given by the number of favorable outcomes divided by the total number of outcomes. Now this is a lot of words, but like I think I've told you guys before, mathematicians like to make easy things very complicated. So even though it's very easy, they write it in a complicated way, but it's pretty straightforward. We're going to do a worked example and I'll show you what I mean. So the worked example I'm going to do is, and I want you to write this down with me, for example, what is the probability of flipping a coin and landing on heads? So what is the probability of flipping a coin and landing on heads? Our first thing that we got to think about is, what is the event that's happening? What is this question actually asking for? What's the event that we want to happen? And we can see here that we want it to land on heads. So our event is heads. So how we're going to answer this question is we're going to say PR, which is the probability of getting heads. So this tells me that we're finding out the probability of getting heads. It's equal to the number of favorable outcomes, which means the outcomes that we want, which means how many possible options are there that we flip a coin and get heads. Well, if we flip a coin, we know there's two sides, so it's either heads or tails. We want heads, so there's one favorable outcome. So do 1, and that gets divided by the total number of outcomes. So divided by, well, in a coin, how many outcomes are there? Well, there's either heads or tails, so it's 1 divided by 2. So the probability is a half, or 50%, or 0.5. So that's how we calculate probability. If you're confident, I'm going to write the questions here. You can go ahead and do this. If you're not confident, I want you to still write these questions on top of your page. I'm going to go through 2 worked examples, and then I'm going to let you guys do it yourself. So on page 570, you're doing questions 1 to 7. So all of question 1 to 7, you're doing question 9, and then you're doing question 13 as extension if you get to that. Also 14 as an extension if you get to that as well. And then if you finish those, there's a worksheet as well. So if you're good to start, go ahead and do that. Good luck. If not, we're going to do some worked examples. So this is the first worked example, and here's what it says. The spinner has 5 equally divided sections. So we can see here we have a spinner. There's 5 options. We get 3, 1, 2, 3, or 7, and someone's just going to spin the wheel. Question A says list the sample space using the given numbers. So question A, if we look back at our notes, remember sample space means a list of all the possible outcomes. So let's think about the possible outcomes. If I start from the top right, the possible outcomes are 3, 1, 2, and 7, but we like to write that in alphabetical, in lowest to highest. So 1, 2, 3, 3, and 7. We only write 3 once, so 1, 3, and 7. Right, so my laptop just died. Let me stop checking. Perfect, so that's that. Go back. So we've listed all the possible outcomes we can get. We can get 1, 2, 3, or 7. Now, even though we can get 3 twice, there's only, number 3 is just, you can only get 3. So that's why I've written it once. Question B says find the probability 3. So find the probability of 3. What this means is find the probability that we spin the wheel and get a 3. So what we've got to do is, if you remember the formula, looking back here, the probability of any event is the number of favorable outcomes, so the number of outcomes that we want, divided by the total number of outcomes. So if you look here, we're looking at the probability of getting 3. We've got to count how many options we can get 3, or how many favorable outcomes there are. There's 1 3 here, and there's 2 3s there. So the number of favorable outcomes is 2, and that gets divided by the total number of outcomes there are. So we've got to count how many options there are now. So 1, 2, 3, 4, and 5. So 2 over 5 is our probability of getting a 3. Question C says find the probability of not a 3. So not a 3. So when we see not, we should be thinking, it's talking about complement, right? Complement. So if we look back at our complement definition, the complement of an event is a probability that the event doesn't happen. So we want the probability of not 3 happening. So we can use formula 1 minus the probability of A. So we can do 1 minus the probability of 3, right? We know that says 1 minus, well, we've worked out the probability of 3 in the previous question. So it's 1 over 2 over 5. Sorry, 1 minus 2 over 5. Pop that in your calculator, boop, 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 boop. You get an answer of 3 over 5. And the way we can double check that is we can look at our wheel. If we want not a 3 happening, there are 1, 2, 3 options that aren't 3. So 3 over a possible of 5 outcomes. That's how we get 3 over 5. I'm going to leave D and E for you guys. So I'm going to move on to the next one because this one might be a bit trickier. So this example says, a letter is chosen from the word probability. Find the following probabilities. What this means is that essentially each letter they've cut up, or they've written a letter on a piece of paper. So P on one piece of paper, R on another piece of paper, O on another piece of paper, and they've put them all into a bag. And they want to find the probability that they find a single letter. So question A says, find the probability that in that bag we pull the letter L. What we need to do is we need to look at the word probability and find out how many L's there are. So we can see there's 1 L there. Well, there's 1 L, so it's a possible of 1 outcome that we want, divided by how many letters are in the word probability. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we had all those letters in a bag and we put our hand in, there's a 1 out of 11 chance of getting the letter L. That's how that works. I'm going to let you guys do the rest. Perfect. Here are the questions again. Page 570, questions 1 to 7, question 9, extension 13, extension 14. This should keep you guys occupied for the 2 days that I'm missing. But yeah, hope you guys have a good holiday. I'll see you guys later.